Welcome to today's explainer. Okay, so have you ever been staring down a task that is just monumentally huge? Like, so overwhelmingly complex you literally don't even know where to start? Well, today we're unpacking this incredible framework from our source material called Architectural Logic and the Computational Mindset. We're going to explore a really systematic method for tackling those overwhelmingly complex tasks. And honestly, by the end of this explainer, you're going to look at massive problems in a completely different way.
To get us started, I want you to just picture this scenario. Imagine you're a librarian, but, not just any librarian. You're standing right in front of this towering, chaotic mountain of literally millions of unsorted books. Millions. It's a scale that's totally enough to make your head spin, right? There are no shelves organized yet, no neat little categories laid out, just a seemingly endless sea of pages and covers piled up right in front of you.
So, this brings us to a really massive dilemma. How on earth do you systematically approach a task of this magnitude? I mean, if you just start randomly picking up books and tossing them into arbitrary piles, you're not just wasting time, you're basically guaranteeing total chaos. You need a system. You absolutely have to have a reliable way to avoid that chaos when you're faced with such incredible, massive scale.
Well, the answer to our poor librarian's dilemma is a framework called computational thinking. But wait, let's clear up a massive misconception right out of the gate here. When we hear the word computational, we almost immediately jump to assuming it's about coding or some highly specific computer skill. But it's actually not. According to the source material, it's fundamentally an essential human survival mechanism. It's a structured way of thinking that allows us humans to manage and ultimately conquer complexity.
At its very core, computational thinking is just approaching problems systematically so a computer, or hey, any human for that matter, can easily carry out the solution. It's entirely about translating complex, messy human challenges into structured, executable solutions. Basically, you do the hard analytical structuring up front so that the actual execution becomes incredibly easy later on.
Now, if we were to map this mindset out, the beating heart of it all is pure, unadulterated problem solving. Every single technique we apply radiates outward from this one single, hyper-focused goal, taking a challenge and systematically solving it. And from that central problem-solving core, we deploy four key strategic pillars. We've got decomposition, abstraction, pattern recognition, and algorithm design. This right here is our systematic pathway. By moving logically through these four pillars, we can take our librarian's massive, seemingly impossible task and actually turn it into something entirely achievable.
Okay, let's break down the very first one. Pillar 1 is decomposition. And this is exactly what it sounds like. Obviously, our librarian cannot logically organize a million books all at the exact same time. That's impossible. So they have to first break that massive mountain of books down into smaller, highly manageable stacks. You take the overwhelming, terrifying whole and you decompose it into bite-sized, approachable parts that you can actually handle.
Moving on, the next step is abstraction, which honestly is really just your ability to ruthlessly filter out noise. Think about our librarian. The color of a book's cover, or the fancy font used on the spine, that is completely irrelevant noise. They must purposefully ignore all of that and abstract the information, focusing purely on the relevant data. Stuff like the genre of the book or the author's name. You just strip away all the unnecessary details.
So once we have those nice, manageable, abstracted stacks, we hit Pillar 3, which is pattern recognition. This is the step where our librarian looks at these smaller piles and starts identifying recurring organizational trends. Maybe they notice that science fiction books frequently have subgenres, or that certain authors often write in long series. By recognizing these recurring patterns, the librarian can create universal rules that apply across all the smaller stacks. And finally, we reach the last step, Pillar 4, algorithm design. Now, don't let the word scare you. Algorithm design is really just the creation of final, executable step-by-step instructions. Our librarian just writes down a precise set of rules for sorting the books. And the absolute beauty of this is that once the algorithm is designed, anyone or any machine can simply follow those straightforward instructions to finish organizing the library, all without needing to understand the whole complex process behind it.
So, those are the four theoretical pillars. But how do we actually get hands-on with this stuff? Let's pivot for a second to what we can call the playground for visual logic. Because a really common question here is, how does a complete beginner, someone who's never even studied computer science, actually practice these highly abstract concepts without getting immediately overwhelmed?
Well, the source material introduces this really fantastic, intuitive visual language tool called Scratch, and Scratch brilliantly teaches this computational logic using literal puzzle pieces. Seriously. Instead of staring at some terrifying blank screen waiting for you to type code, beginners literally just snap together these visual puzzle pieces. It makes the abstract pillars we just talked about, like algorithm design, super tangible, incredibly accessible, and honestly pretty fun to interact with.
And this visual playground solves a huge hurdle for people, the fear of syntax. There is this massive fear out there of having to memorize complex coding syntax, where a single missing comma literally breaks your entire program. But Scratch doesn't care if you miss a comma. Its sole purpose is to train your analytical mind in pure logical reasoning. It's all about training the mind first. Okay, let's zoom back out to the big picture here, the machine-ready mindset. Mastering our librarian's organizational logic perfectly mirrors the exact same mindset required for advanced architectural and computational fields. Whether you're architecting a massive physical building or writing a super complex software program, you are relying on this exact same underlying framework to navigate complexity and bring order to chaos.
So to really distill all of this down, this framework allows us to translate big human challenges into clear structure. It helps us develop a razor-sharp analytical mind and ultimately create machine-ready solutions. Really, computational thinking is simply a highly accessible framework for converting massive, intimidating obstacles into systematically solved processes.
So as we wrap up, I want to leave you with this final kind of provocative thought. Take a second and think about your own daily life, your work or your studies. What are the millions of books in your own life right now? What is that overwhelmingly complex mountain you're currently staring at? And more importantly, using decomposition, abstraction, pattern recognition, and algorithm design, how are you going to systematically compute a solution? Thanks so much for joining me on this explainer. I really hope this sparks some amazing ideas for you.